So we are now focusing on question 3b. Find the range of each function for a given domain and state if the function is one-to-one or not. So you are given the domain to use. This question is asking us to understand what the domain means. Okay? You are given a function f of x is equal to x minus 2. This function, the only x values you can use are the ones that are coming from this domain. So if you use n of those numbers, what numbers do you expect? Give us an interval. So since the power we have is 1 for this function, we simply substitute the lowest number, negative 2. So we have minus 2, which is equal to negative 4. We also substitute positive 4. So we have 4 minus 2, which is equal to 2. And say, okay, so meaning the range is from negative 4 to positive 2. Since they are all included, we also include. Since the power is 1, we substitute the lowest number and the highest number to get the range. Is it 1-to-1? Obviously, this one is 1-to-1. Okay? Because there I know you can easily show f of a equal to f of b, and then you subtract them. Now let's go to part 2. Part 2 from negative 3 to 3, and it is squared. So if you substitute negative 3, we are going to get negative 3 squared, which is 9. If you substitute 3 squared, 9 again. So you can't use the end to give you the range. You also need to understand the function you're having. So we are having x squared. So meaning we must also substitute the 0 if it is there. Now 0 is in this interval. So we'll substitute 0 as well. So we'll get 0. That means that the range is from 0 to 9. So 0 will be included, but 9 won't be included because negative 3 and 3 that gave us 9 are not in this set. That's the idea there. Hello.
Yes, why did you include a zero here, but on the first one we didn't include a 0?
No, I see.
Yeah, no, I mean, like, why did you use it?
Come again.
I'm saying on the first part there, we just used the numbers that were given, that's negative 2 and 4. But here on the second one, we've used negative 3, we've also used 3, but we've also used 0, like f of 0.
Because of the power of x. So when the power of x is 1, you just pick the order given, the lowest and the largest. But when the power of x is 2, I'm demonstrating that if you use the lowest and the largest, they have given us the same number, 9, 9. But when we go and get 0, which is in between.
Since the power x is squared, so you have to use 0?
So because it's squared, we also have to use 0 because 0 is neutral. It doesn't have a sign. Okay? So let's move. So that's how you get into the issue of the domain. And the 1-to-1, I'm not worried because we just test f of a equal to f of b, and then solve it. You get a equal to b, then you have a 1-to-1. Okay, then question 4. Find the
Mr.
domain.
Keith,
Hello.
you said how do we solve the third question?
You substitute 1 in here, you get undefined.
Oh, sorry, no, the one on top where we have g is equals to 2, I think also negative 2. Read it.
3a, we are told that G2 is -5. So what G2 means, where does x put to? And equate it -5. G -1, where does x put -1? Then equate to 2. Then you solve simultaneously.
Okay, thank you.
So G of 2 is a 2 squared minus b. Now we are told that it is -5. So you have 4a minus b. You are also given G of -1, which is a -1 squared minus b. That is 2 is equal to a minus b. So you solve this and this one simultaneously using any method that you know. Substitution or elimination. Both of it. Find the domain and the range of the following function. You know, you can't go in an exam and don't find the domain. So you have to find the domain. The denominator, you make sure that x is not equal to 0. I mean that the denominator is not equal to 0. But if you look at this denominator you have here, it is x squared plus 1. There is no real number that you can put and square, and when you add the 1, it becomes 0. No. So you say all real numbers is the domain for A. Is that fine? So the only two questions that you're answering, you want to, hello?
Since when we start graphing the first of functions, we normally say the domain.
I couldn't get what you're saying. So if you ask to find the domain of this function, your target is you want this to be greater or equal to 0. It's a quadratic, so you need to factorize it. Then you equate to 0. So you equate to 0 to get the critical numbers, and then you go to a number line to see where it's minus positive. If I pick 0 here and substitute there, I'll get a minus, so it's plus, plus. And you want it to be greater or equal to 0. So you say the domain is equal to minus infinite up to -1 included, union 1 up to infinite. So the domain that involves greater or equal to will lead you all the way up to the number line or the table. So I'm trying to show you how to study a Excel sheet, how to go through Excel sheet this time around. It's not question by question that is solved. You solve from A up to I, no. You solve to get the concept and move on. Here, you just get f of g, f of g, g of f, things that you know, there's no need of solving. You need to check the functions given below are either bijective or not. Bijective means it's one-to-one, it's also onto. So if the given function is bijective, find its index. So if it's invertible, you find the index. If it's not, restrict. So that's not one of the questions that are expected anywhere near. Because they may involve a lot if they are to be of this kind. So it's not something that we can worry about. Maybe you can want to explain why a straight line parallel to the x-axis will intersect the graph of a one-to-one function at most once. So if they say explain why, they just ask you to define what it means by one-to-one. The answer will be because for one-to-one, f of A equal to f of B implies A is equal to B. It explains why a line cannot touch twice. Because if it touches twice at different points, the same value, giving you different values of y, then it means that because one-to-one demands that the same A that gives you f of B should be equal to B. So you just really define, give a definition of it. So you see, one exam paper is making us run through the Excel sheet. We cannot solve the f of g because it was there in the paper that we saw. We're not worried about these minor domains. This is least expected. So I don't bother much. Determine whether the given function below are even, odd, or neither. Something that we really spent time on. Maybe you'd want to look at this one. So you check if what f of negative x is. So it will be negative x plus 1 over negative x. So you see that it's not the original function, so it's not even. So because it's not even, we want to check if it's odd. So we multiply the whole function by a negative. So it will be negative x plus 1 over x, which is negative x minus 1 over x. So now you see, this guy we have is equal to this guy. So f of negative x is equal to negative f of x. So f is odd. Like that. Please don't even confuse them. Just look at the definition. The same way they are defined is how they are. The diagrams below are graphs of real functions. Which of these graphs represent functions that are odd, even, or neither? Even means if I substitute negative 2 or positive 2, I get the same value. Then it's even. Or if the line of symmetry is the y-axis, then it's even. So if you look at A, when you fold the A, the line of symmetry is the y. So A is even. The same way B is even. You can fold B on the y-axis. But you cannot fold C on the y-axis. So C is not even. Okay. C is an odd function. Because when you substitute a positive value, if you substitute this value here, it will give you a positive number. But if you make it negative, it will give you a negative value of the same value, that one. So you see, this is 2, this is -2. So f of negative x is giving us negative f of x. Of course, f is even, E is an odd function, and D how is D? Well, D is neither.
So how are you telling these things?
What if I write for 2014 where the question which we can ask from those things? How would you tell that it's that it's even or not? Yes. So here I've explained that an even function, you want to see, even if you take a negative number, you're getting the same value. So even if you take this value here that is negative, this is -3, it gives you the same value as +3. The value is there. So that's why you know that it's even. Or you draw a line, horizontal line. And when you do this, the difference between the numbers is just a sign, but same numerical value. If it is 3, the other side should -3. Then you know that it's even. The same thing happens here. If I do this, okay, when I come down here, this value should be the value on the other side. The only difference should be one is positive, one is minus. then you know it's even. Or you look at the symmetry. Where am I folding it? When I fold, I can't see the other side. Like this first question, if you fold around the y-axis, everything will be covered. Then you know it's even. Be the same. But if you fold along the y-axis, you can't have your side. You suspect that it's either odd or neither. For the case of C, if you fold it along the y, you have the endpoints meeting, but these in between won't. But if you fold along the line y is equal to negative x, it will be covered. Then you know that, oh, it's an odd function. Because I'm folding along the line, y is equal to negative x. That's why I said even this one is an odd function. But if you look at this one, this value and that value, the difference, I think it's also on the sign. The positive one gives us a negative, and the negative gives us a positive. So if you make it negative, it will give us the same value. So this should be an odd function also. So this is even. Odd. Even. Odd. And this is odd. Because the only difference is that if you take a negative, it gives you a positive. I mean, it gives you a positive. If you take a positive, it gives you a negative on the other intervals. So they just switch. So that if you multiply by negative, you still get back the number you get if you put a positive. That's what it means. Though. So they can ask you using the graphs, they can ask you to check whether it's one-on-one. I mean, one-to-one where you draw lines. Like that. Okay. I think sheet 2, those are the most important things then. Other things are less important. Yeah. Okay. So temporarily will end here. I will gain some strength. Come back after some good hours. By gaining my strength very fast, I will communicate. By delay, I also communicate because we're likely to have a class at 5. We do fellowship 3, maybe up to 5. We start from 5 up to 7, we can cover by a good number of sheets there. I think no one is going anywhere. No class. So you'll be in your room or in your body on this. So I'll communicate the time. Bye-bye.
Okay, sir.